Hello, Suraj.
Good afternoon, sir.
Hmm. Voice,
Is it clear, sir?
it's clear.
Okay, fine, sir. So no need to use earphone.
So you have made the professional. Hmm?
Yes, sir. Yes, sir. Actually, that was I decided to in last time I was presenting, but
You
due
have
to the due to lack of
already
time,
you
I,
have
yes, sir.
you have already participated in number of webinars, no?
Yes, sir.
So that is what the idea obviously coming in your mind. So that
So
is
what
what.
sir, many colleges are just organizing this type of seminar and they are making posters as well as many different colleges are participating from for single college. So I decided to why not to make a poster for that. So I post everywhere.
Already, I
Actually many of
thought
yes sir.
I thought 15 days before, but I know that when I have started this one,
Yes sir.
so director put everyone on the line that everyone should do it, and everyone was think that I'm the villain. Okay, otherwise I have just most probably from the SESI side we plan to make a webinar
Okay.
because 70 80 students they have already enrolled now.
Yes sir.
So SESI I have already talked with them. We're getting their approval. I think in the first week of the June
Okay
we are
sir.
organizing a national seminar
Okay, sure sir.
if possible. I will take the help of yours also at
Yes
that
sir. I'm
time.
always sir. No need to tell.
Today, the topic is FDM,
Sir. FDM.
everything about FDM manufacturing.
Okay sir. Sir. Fine.
I have changed the time.
Oh, actually, sir, I
The
have
time changed.
another.
Okay.
Okay, okay. Actually, sir, I have another FDV program in actually. For that, I have registered and continuously I am attending that
Yeah.
from 26 to that will
Today,
be.
today,
Yes, sir.
today I will share another one.
Okay,
Okay.
sir.
Today I will share another one to you,
Okay, sir.
and I think that will help you also.
So definitely, sir. I am
Just now I will
actually
share it to you.
okay, sir. Definitely, I
It is
will be
5 days.
waiting.
Five,
Okay. Currently, I
five
am
days related to manufacturing.
okay. It will be very much helpful to for me.
It would be better that if you use Google Meet.
Yes,
Suraj,
sir. Yes, sir. It's little bit okay,
what
but Google Meet is not that much of user friendly. But in case of this Google Meet, it has a lot of parameters to
because
control.
some interruption will be there now.
Yes, sir. Lot of parameters are there so that we can control that network settings and control the all the participant through the host. But in case of Google Meet, we are unable to just control that thing. So there is so much disturbance is there. So we need to request number of time to participate to put their mic in silent mode or off. That's the big problem in there. And another advantage in Google Meet, in Zoom platform that we can record the session, whole session, and later on we can use that for recorded session of any webinar. So that feature is not available in Google Meet.
Suraj,
Yes, sir.
already 15 participants have joined. Are you waiting for some other, or you can start now?
Actually, waiting for some more participants to start it. Actually,
Okay.
actually, sir, when I sent the link to participant, that was around 5,000 number of participants, 5,000 around. So
Good.
it's very few number of participants here. This 16. That's why.
Have you sent the reminder?
Yes, sir. Yes, sir. I have sent that will remind before the 10 minute ago of
Because every
this.
people is busy.
Yeah, right. Actually, this is a long time exactly. So that's the problem. So it's the one time
Okay.
webinar. So we
You
can
wait
start.
for 5 minutes.
We can start within 5 minutes.
Okay, no problem.
Okay, sir.
We wait for 5 minutes, then you'll start. Huh?
Okay, sir. Today's session is very interesting session and containing lot of information regarding the manufacturing process. So it will be must be interesting session. Very good afternoon to all here connected with us. Today's topic is very nice topic. This is everything about FDM, manufacturing technology actually. So it has a very big, vast area. So within 1 hour, it's very difficult to complete the whole thing about this FDM. It's a small. You can just can say this is the small part of additive manufacturing process, but it will take much time to complete. But as I will try my best to complete and try to give the vast amount of knowledge regarding this FDM. So let's start this session. So these are the contents we are going to discuss here. So you can have a brief glance on this. So first we'll see. One is So first one here, this is rapid prototyping and additive manufacturing process. So first of all, before going to the topic, we can just get the concept of manufacturing process. Now, this current era, we can uh, just visit in two way, like two way of manufacturing process. Like one is additive manufacturing process, one is a subtractive manufacturing process. And substance manufacturing process is a traditional type of manufacturing process where we do what a bulk of material we bring from the ore and make for the refining. Lot of processes there. After getting the fine material, we just put it for the number of process to make a dedicated product as our requirement. But in case of additive manufacturing process, that what happens, that material we are using are or the bulk material we are using are not by cutting material, by removing the material from the bulk material, but here what happens, that material we add material in different in different criteria, like we can add line by line or layer by layer. By adding that material we can achieve the our final product. So so here the additive manufacturing process can be in three way, that is fused deposition modeling, that is our main area of discussion, and selective lasering and selective laser sintering and stereolithography. These are the another vast area of discussion. So now see, these are the types of additive manufacturing process. Generally, the additive manufacturing process can be called this 3D printing manufacturing process. So these are the several type of 3D printing manufacturing process. We can go the brief regarding the this several type of manufacturing process, but uh, we'll focus on our main topic, that is metal extrusion or material extrusion 3D printing process. So first of all, we will see the vat polymerization, that is a SLA 3D printing process. So this is the vat polymerization or the SLA stereolithography apparatus. That means whatever that our product we want to make or we want to manufacture a product. First of all, we need to go for the designing of that product, and there's a lot of steps are there. Regarding the step I will discuss later. But what is this vat polymerization? That vat polymerization means there is a liquid resins are there, you can see here. So this is a special type of resin. When that resin come into interface of UV light, that gets solidified, and that permanently gets solidified, and by that solidification of that liquid resin, we can achieve the product. But the challenges is we need to that put that UV light in a particular path or particular meshing of object. That means we can get our desired product. So that path are already are predefined through the different softwares are there, and that will be defined by the software, as well as we can define that path by ourselves by editing manually. We can edit that. So so you can left side image, we can see this is schematic diagram of this printing. So you can see these are bat are there present. There is a photopolymer resins are there. Actually, why this photopolymer is called? So photopolymer means the polymerization takes place by the presence of lights. That means when the light is present, when the light is come in contact with the resin, that gets solidified. That's why it's called the photopolymers. So these are the few this setups are there. So there's a lasers and optics are there. So if anybody have any doubt, that can ask in the end of the session. So we have this is a powder bed fusion distributing process. Here the SLS, the selective laser sintering. So here selective laser sintering means sintering means here the defines that sintering, that is compacting of the material, and the compacting of the powder material by or through the laser heating process. Here laser plays a vast role here. Here whatever that you can see the left side image, there is a building platform is there. We can see the powder beds are there. You can see powder bed is here. So when the material coming from this new powder stock, that the roll is present, that roll by rolling that brings that powder material to this printing area. After being that powder material here, so there is a laser source are there that contain vast amount of energy. By that laser beam, that material gets that material get melt or liquefied, not totally liquefied, it's just semi liquefied, so that it can attach, it can just join that material that already present in lower of that current layer of powder material. That means the solid layer will be at lower of this current layer. When the material of when the powder material get heated by the uh, laser beam, and when the passes the laser beam through the a certain pattern or certain path that was defined in the software, and according to the that material will get melt and get solidify, and we can get that our product eventually we can get our product by layer. So material jetting is another type of 3D printing process. Here what happen, that material also get as a but powder material present inside of the chamber, and that material just came that powder material just came in the printing area. But in this case of there is a filament, that is not filament exactly, there is a tube like shape is there, and by the tube we provide that material through that tube, and the droplets of the material that deposit on the top layer of on the previous top layer of the product. And after putting that material, that another source of UV lights are present, and by that what happen, that UV light or that is laser will just melt the material, and once the melts the material, then get bind together. So there is a formation of there is a small layer of solidified model, and after continuously repeating this process, we can get the our product. So this is a binder jetting. Here whatever there is a binder jetting whatever, there is use of two types of materials there. One is the main material, and another is the binder material. Here that main material, as before in the laser sintering, selective laser sintering, as that we have the powder material is there. But in case of there is a material of that product we are going to, that material is, but there is another material to bind that each layer of the material, so that by binding the material or binding that that powder material together, means a layer by layer, by binding that material, we can achieve our final product. So this is the powder bed fusion, and here several types of this there. So you can see here the direct metal laser sintering, SLM. This is a selective laser melting. EBM. This is electron beam melting. Here all the area that direct metal laser sintering is that exclusively used for the metal generally, as well as there is a in case of the electron beam melting, there is a source of vast amount of electron to heat the material. But in case of a laser sending, whatever, that source of energy is laser, means the light. Light will heat that material, and in this case, the laser will. In this case, the electron beam will melt that material. This only difference between the source of energy or source of heating element. So there is not so much difference between DMLS and SLM. We can see this another name of you can see very similar to these two types. So now we'll go our main topic is that what is the FDM. So FDM is the fused deposition modeling. That modeling can be get through the fusions of material. The fusions of the material. So we can see we can get that it is a fused filament fabrication also. Why it is fused filament fabrication? Because the use of the material is similar like a filament shape. That means a spool of a filament that wound upon a spool that get fitted into the heating element of the 3D printer. That's why it's called the fused filament fabrication. So by this FDM 3D printing process, so objects are built by selectively depositing the melting material in a predefined path. That predefined path already defined by the software, different slicing software. So here we go for the detail about the working of FDM. So you can see we can have the knowledge of this FDM. You can see this schematic diagram. There's presence of nozzles is there. The objects we are going to be present or we are printing is here. And we can see there is a supporting material. Regarding the supporting material, we'll discuss later. So this is the building platform. Gentlemen, this is a platform where that main. So here the nozzles and heating element. Nozzles and heating element are just connected together. The heating element are the main source containing the resistive heating element type. So by
Suraj,
yes sir.
you please mute everybody. Some people are talking.
Yes sir. Let me give
Mute everybody. Mute everybody.
So now we'll start again. So you can see here this image. Mm, this is a bed and this object is that we are. This is printing. You can see this arrow mark is there. That means that this head is passing through this like this shape. We can get this exactly not like this. We can also define the path how that head will move. That will also define in slicing software, and there is a different parameters are there. So that will discuss later. So this is spool metal that I was saying. This spool of filaments are there, and filament will feed it into this heating material. There automatically this plastic material get melted here, and there is a extruder is there, and extruder whatever that filament just pull inside the heating element, so that by the controlling of that extruder we can control the output of material from the nozzle. So there how much nozzles how much material need to be draw from the nozzle that can be controlled. Okay. So this little bit what I have told before. So here we see the printing process here. So there's several process with the step we will discuss here. So first of all, we'll go for the designing of the 3D model. So before going to print any object, we need to design uh, from design it from a CAD software. So we'll go for the designing of CAD model. So here the different softwares are there. The SolidWorks, parameters, the modelings are there. AutoCAD, Tinkercad. So you can see this image shows that how the model can be designed in SolidWorks. This image also show how the solid model can be designed in CATIA. There are several software we can design. There's a Creo, there's AutoCAD, there's a Tinkercad. And this Tinkercad is very useful software. By this software, we don't need to vast skill regarding this 3D modeling. Just have the knowledge regarding the which shape, what are the name of the element, we can get that 3D object. No need to require a vast skill regarding the measurement engineering, drawing as well. By this Tinkercad, a kid also can design a 3D model. So you can see this is a very simple software as compared to the other CAD modeling software. So this Tinkercad is a free sources is there, and anybody can use in a browser also. No need to install the software. So here you see the generation of STL file. So STL file is plays a vast role to make a 3D printing object. Before going to the slicing, is STL file plays a very vast role. So to make a CAD model to convert into STL file is very simple. We can just export export that same model. What we want to just convert to STL file. Just before saving, we need to just click on the save tab. We can change the STL file. So by that we can achieve that STL file of the CAD model. So here, actually, what is exactly different? You know why we need to convert the STL file from the CAD model. So you can see this STL file and CAD model. This first image, you can see that first image shows that this is the CAD model and the STL model. A CAD model, you can see there is a continuous lines are there. Continue means there is a round shape is there. But in case of STL file, that converted into a straight line. Uh, the whole object, the whole model is converted into a vast number of triangle or pyramid shape. Because these shape required when the any type of we go for the CNC or any, that means we need to these shapes are made because our print head need to just move, and print head should know the which path need to follow, and what should where should we go the that head of the printer. So this concept also act on in CNC machining also. So here you can see this is a deep concept of the STL file. You can see these angles are there. So this vast area we get to get knowledge regarding the STL file. So if any you have any doubt, you may ask later. So this is the slicing is another main step for the 3D printing process. Slicing, its name suggests that slicing is cutting of anything, means cutting small pieces, like slicing any fruits or slicing of any vegetables. That meaning is same. But in this case, the 3D printing slicing is that the object will slicing in a very thin layer, means that printing machine, that 3D printer will move layer by layer. So which layer printer should move at first, which layer printer should move second after that layer, and that will be defined by this slicing software. And slicing also define that the printing time, layer height, there are several parameters are there for the slicing. So we you can see this is the image of the slicing, the right side image. So you can see this is the Cura software. By that, this is Cura, this free software for the slicing. So this is one of slicing software. This slicing software name is IDM Maker software. We can see this object. Actually, this 3D model of a gear, and after gear modeling, to convert in STL file. After getting the STL file, we'll get input of into the slicing software. After getting the slicing, after getting into the slicing software, we go for the different parameter to set how it will print and how what the several parameter will see here. So these are the several parameters, sir. So you can see this advanced settings will provide that layers parameter. You can see there's a general setting. The layer height is there. How much should layer height? This is the 500 micron of layer height, and cell. Cell means this is the outer layer of any object. That means outer layer of any object means how many lines, how many layers should be built with cells material. That means outer layer only hollow, but removing the hollow part, removing the material from the inside of any object, and only considering the outer layer. That is called a cell. And the cell, how much layer, how much layer we need, that will mention here. That means two layer I need. That means two layer will print outer cell, then it will print other, and like that is several parameters there. One by one parameters plays a very vital role. The first layer height, how much first layer height should be, and there is a also we can see here later. So here extruders parameters are there. Extrusion width, retraction also. Retraction plays also very vast role, and costing also. By this extrusion, we can just get how much cost will it take, and by after the slicing, that cost also can be calculated from this. Also, the before going for the printing, we need to just feel that properties of the filament, that density of the filament. By that extruder parameter also changes, because the extruder will just put the material into the heating material. That means when the material get melted, that density also plays a vast role. Due to the density, we need to put several forces in extruder. That means we need to force 1 meter per second. That means I am saying for in an example. By that we need to control. By that we need to control in different parameter in extruder also. So at the end, we achieve the what we after slicing, we generate the G code file. After getting the G code file, we give the input to the 3D printing machine. After getting the input of the G code in the 3D printing machine, when we start the machine, it will just print layer by layer. So you can see in the left side image, we can see the each layer. Actually, this macroscopic image is there, so it's unable to. Actually, it's very easy to understood each layer, but in this image, in right side image, actually very difficult to see these layers. So now you see the different filaments are used for the FDM rebuilding process. So these are several parameters. There's a few materials are there: PLA, PLA plus, ABS, AB plus. According to that, there's several parameters. The printing temperature is there. That printing temperature, bed temperature, what required the bed temperature, density of the material, the tensile strength. There's several strength. According to the strength, our object will get a certain our strength material. That means we need that much of strength of material. We need to go for this material as well.
Suraj,
Yes, sir.
hello. What is melt flow index? What is it?
Sir, melt flow index is regarding. That means I think it's actually I'm not clear about this melt flow index. Actually, these terms I have not used.
The unit is given degree centigrade per kg. I think
Yes,
both the thermal as well as the mechanical pressure
Yes, sir. Yes, sir. Actually, that need to go for
being
more detail
engaged.
regarding. Actually,
That
I
means
have not.
first you have to melt it. I
Yes, sir.
think first the powder has to be melted
Yes, sir.
and then pressed.
Okay. Sir, this is not the powder. This is the solid material, solid filament,
That's solid
thread-like
material.
structure, thread-like structure.
Made flow means after melting it will flow.
Yes, sir. Yes, sir. I don't have
Okay, I think.
that clear knowledge regarding this. Actually, I have not used this term before this session. So I will
Okay,
go.
okay, carry on.
Especially, I will go for this term in my 3D printing machine.
The
So
rest of the parameter is well understood,
yes, sir. Will
but
understand. Yes, sir. Okay,
thing
I
is
will go
continue.
for this term. I will go for this.
Okay, okay,
This.
continue.
Okay. So here, this is a picture. I've seen that there is four filament types. I've shown that whole parameters. We can see the 3D printing filaments are purely 100% virgin materials. No recycled materials are used for the 3D printing filament. Actually, generally, the 3D printing material are also certified of ROSS certified. That means ROSS certified means that will not affect of but environment not sensitive. That means that is the term actually. The full form I'm able to remember that word. So that is not a toxic. We can consider that ROHS. Oh, restriction of hazardous substance. That ROHS full form is. So the filament we can get several colors are there. So here the several colors. We should not get confused these colors and this name of the filament. Any filament. This means PLA material of PLA material we can the number of color. This means for the PLA material we can have the black color, red color, any type of color we can get. There's a color. We should not go for the this color coding of this material name. So this only for the graphics only, not much. So here we see the post processing. So after 3D printing process, the each object or each product we achieve from the 3D printing process, there is formation of several roughness of on the surface because the printing process takes place layer by layer, and the roughness also depend upon the layer height and printing speed and types of filament, temperature of filament during printing, and filament speed of printing also. So due to this parameter, that roughness of the object also depend. When the speed of the printing is high, that means we can speed more than 100 to 150%. That printing quality definitely decrease. When we decrease the printing speed to 50% of printing speed, then the surface finishing also definitely increase. Due to this thing, when I required a number of object at a shorter time, we go for a fast printing process. So there is a formation of several roughness and several roughness are there. So for that we need to go for the post processing. So there we can see this is a grinder, a small grinder. We grinding the surface of this object. So there is a special type of knife. There is ultrasonic knife also used for the cleaning of extra parts. There is support material. So I have said regarding the support material. Actually, support material what happen. So you see the next image. So here you can see in the left side image you can have the this white color and red color. This white color we can get. This is the supporting material. That means to print this material, we need a supporting material that it will support when that nozzle will pass in a free space. That cannot be print in free space. That required in a resting bed or resting surface required. For that, for any extension after the some height for the any extension any around the printing, so that definitely require a support area. That means during the printing of that object, the first of the object, that supporting material supporting object also printed with the main object. So the supporting material also plays a very big role to get the exact shape of our product. So this supporting material, after removing this supporting material, we can achieve this after the post processing. You can achieve this right side image. You can see here. So to remove this supporting material, there is use of several tools. Like I have said, there is ultrasonic knife is there. Ultrasonic knife, we just need to touch that any surface or any area that you want to cut. We don't need to put a high amount of force to cut there. That will due to the high frequency, that frequency lies around 50,000 to 80,000 of cycles per second, that frequency, that horse. Due to that, that cutting take place. So also the supporting material, we can set the parameters, different parameters also. Though how much distance should maintain that our main object and the support object, and that also we decide in slicing software during that before generating the G code. So after generating the G code, we can't change that any parameters. So definitely go for the this parameter before going to the G code. Actually, G code only when we achieve after doing all the process, and G code is the final code we feed to the 3D printer machine. So now we see the several applications. Nowadays, the 3D printing take place. 3D printing is everywhere, fastly using in fastly used in aerospace engineering, digital dentistry, eye care, prosthetic hand, automobile industry, and household goods, craft. Many other things are there for the education process, education purpose. The use of first use of 3D printing machine. So here you can see this image. A kid don't have that hand, means for the accidental case, that hand was actually the fingers are just cut down. So by the 3D printing process, this is a man. That hand with the 3D scanner is there. By the scanner, that man is scanning the hand outer surface. After getting that outer surface, by this 3D scanner, we can get the 3D model from that model to exact 3D model. That practical product to 3D model in software. In any software, that may be a SolidWorks, CATIA, whatever the other software, that we can achieve without going for the any reversing, without going for the any measuring terms, like this 3D scanner very vastly used in reverse engineering. So by scanning of any object, we can get that object in our system, and after that we can print directly. That means the duplicating of the project, duplicating of any project or any product. So this is another application. We can see this is a medical application. As you can see, there is a eye care, prosthetic eyeball, and 3D printing machine has vast application in medical also. And the medical line 3D printing application has vast area. Discuss regarding this, it will take much time. So we go for the next. There is the challenges for the 3D printing process. So generally nowadays we face the challenges is affordability. So affordability means that cost of the printing object. That means to print a small cap of pen, that will take around 10 to 20 rupees minimum. Actually, I am guessing the price actually by comparing the cost of the filament. Actually, it's simple. Commonly use the filament, the PLA filament, that cost around 900 to that's 1700 rupees, according to that quality of the filament, and by that we can compare the cost of the product. So to print any object, it needs much costlier than other type of manufacturing process. But we can go for the 3D printing process, but those product we are unable to just manufacture from the other process of manufacturing process. And another is quality of print. From the last 20 years, continuously the researchers are going for the increasing the quality of printing. First of all, that invention of that FDM was there. So first FDM is there. Then for the increase the surface finishing, we go for the VAT polymerization. In this case, the VAT polymerization is very fine surface finishing. Actually, in that polymerization, it can achieve much surface finishing as compared to the fused deposition modeling. In case of this laser sintering process also, that metal laser sintering, so we can achieve that much of surface finishing as we can get in VAT polymerization. But the disadvantage is in VAT polymerization is the surface finishing we can get, but disadvantage is that very slow printing process. And print a small bottle, a small cap of a pen, it will take around half an hour to 1 hour also to print that. It will take very printing speed is very slow. So here to replace the different function parts in industry and 3D printing parts. So erection of defect during printing. That means during the printing process, that means a printing process will take around 6 hours. That means when in case of any defect come after the 3 hours, after 3 hours of printing, to reduce the effect, at that time it's very difficult to get the final product. So we need to just go for the reprinted that model, and that we reprint that model, that whole previous model will get, the previous product will get wasted. So this is also the challenge. Repeatability, just we can consider it for the advantage as well as the challenges also. So repeatability here, the printing speed take place very vast role. So the printing, if the printing speed is high, you can achieve that product, a number of product in shorter time. But it's very easy to repeat any object in 3D printing process. But due to the defect in environment, defect means there is if there changes in the environment, changes of the printing area, changes of any parameters in the physical machine of the printing, there will definitely come the challenges in 3D printing process. So thank you very much for listening. So here I welcome to all the questions you have. Actually, I'm one meeting to all here to accept. Yes, sir. I have all muted all participants, so one by one can ask question.
Hello, Suraj.
Yes, sir. Yes, sir.
Other college students have joined.
Yes, sir. Actually,
other college students joined. Are there any
yes, sir. Yes, sir. Few other college students this is have joined, but they are not responding at all. They have muted themselves. Actually, they are interested. If they have interest, they can ask the question. We can force them.
Okay. Anyways, the presentation is very nice. Though
I
related to this topic, because my area is something different. I'm least knowledge about all this manufacturing process. But as usual, you have prepared so professionally all the slides, all the diagrams, all the information you put so nicely. It is appeared that you are not a fourth year student. It appeared that you are a professional.
It's very grateful to me that your words.
Anyway, so my best wishes to you.
Okay, thank you very much, sir.
Okay.
Thank you very much.
Also, you can also be connected with some of the universities, some of the manufacturing units.
Yes,
right?
sir.
Because now this is now the new trend just just begun after this COVID. That is the
Yes, sir.
webinar.
Yes, sir. Yes, sir.
And there, so opportunity will be there. Okay. But anyways, so your presentation is very nice. Okay. Happy. Next
Okay.
time
Thank you,
also.
sir. Thank you, sir. Thank you very much. Actually, last time there is a
Seek your
problem.
help.
Okay. Thank you, sir. Actually, your words I always remember doing anything, any work. So actually, last time there is a problem of network. So it is very thankful to also network system that I have very good bandwidth so that I can speak to everyone and my voice is audible to everyone. No disturbance came.
Okay, so no disturbance. It is very clear. Clarity is there without any interruptions. The pace is also good.
Okay.
Everything I think for a presenter part, it is very fine.
Actually, this whole thing has done in 2 days.
Okay, Suresh, thank you.
Okay. Okay. Thank you, sir, and thank you to everyone to listen to me. And actually, this session was recorded. If anybody want to listen this session, I will share.
You can send to me.
Yes, sir, definitely. Actually, this file will be very last file.
You can.
Yes, sir. Yes, sir. To get actually no interruption will take place. Anybody anywhere can get this session. So thank you everyone for the attending this wonderful session.
You do one thing without
Yes, sir, yes.
taking the long. You just like some clippings. Okay.
Okay, sir.
You can also some clippings you can put because if you show everything, huh? So I think it will be more effective if you put some clipping in
Yes,
your
sir.
YouTube that somebody will see it. He or she when is getting interested,
Yes, sir.
definitely he will also contact with you. Hmm?
Yes, sir. Definitely,
So
sir.
the overview of it.
Okay, sir. Okay, sir. Excellent.
Because
Okay.
I have a friend in Bangalore.
Okay, sir.
Okay, he was from Angul. Now
Okay. Yes, sir.
is like different types of managerial skill and development like upgradations and different types of what I can say FDP programs. He is just conducting from Bangalore to different part of I mean not only India, also in abroad.
Yes, sir.
He is posting. He is posting. I can also share his what is that WhatsApp or link to you. Hmm?
Okay, sir.
I
Okay,
think
sir.
you will get
Definitely, it will be
benefit
so.
out of it.
It will be so helpful to me.
Now he is a very famous person. Previously he was working in Ungur,
Okay.
and now he is in Bangalore, and he is connected with different countries. His job is that he is having different webinars connected with different managers. Particularly,
Yes, sir.
he is
Yes, sir.
planning from all the corporate sectors.
Yes, sir.
Okay.
Okay.
Okay. Anyway, Suresh, thank you very much
Thank
for
you.
your
Thank you,
presentation.
sir. Thank you, sir. Thank you everyone for joining with us. So now I am just ending the session. Thank you everyone.